Welcome to this hands-on session on ClusterIP services in Kubernetes. ClusterIP services allow pods to communicate internally within a cluster. In this session, we will create a ClusterIP service. We will use both the declarative YAML method and the imperative kubectl method. Finally, we will learn how to debug and verify the service. First, let's start by the declarative method using the following YAML. We will explain a service YAML line by line. The first line is AP version, v1. This specifies the Kubernetes API version for the service resource. Next, kind, service. This tells Kubernetes that we are creating a service object. Under metadata, we have name my ClusterIP Service. This is the unique name of the service. The spec section defines the behavior of the service. Inside spec, selector, app, nginx. This tells the service to target pods with the label app equals nginx. Only these pods will receive traffic from the service. Next, ports. Defines the ports exposed by the service. We have protocol, TCP, which is the network protocol used. Port 80 is the port that the service exposes internally inside the cluster. Target port. 80 maps this service port to the container port inside the pod. Finally, type, ClusterIP. This makes the service accessible only within the cluster. It does not expose the service to the external network. To execute this YAML file, we use the command kubectl apply-f clusterip.yaml. Now let's create a pod to which service will send traffic. kubectl run my pod --rm -it --image equals nginx --labels equals app equals nginx. We can also create the service using the following imperative command. kubectl expose a pod, my pod, --port equals 80, --target port equals 80, --name equals my ClusterIP service 2, --type equals ClusterIP. Here is what each option does. kubectl expose pod. My pod creates a service for the pod, --port 80, sets the service port, --target port 80, maps to the container port, --type ClusterIP, ensures the service is internal only. This method is fast and useful for testing. After creating the service, let's see how we can debug and troubleshoot it. First, list all services using the command kubectl get svc-n default. This shows service names and their ClusterIP addresses. Next, describe the service using the command kubectl describe svc my ClusterIP service. This shows that the service is of type ClusterIP, with label app equals nginx, exposing port 80 and forwarding traffic to pods with the same label. Its ClusterIP address is 10.96.165.15 and uses its selector app equals nginx to find matching pods. It then forwards traffic to their endpoints, in this case the pod with IP 10.244.0.141 on port 80. Then, check service endpoints using the command kubectl get endpoints my ClusterIP service. This shows which pods the service selects. To test the service from another pod and check if it forward the traffic to our nginx pod, we can run a temporary pod to access the service using the command kubectl run busybox --rm -it -image equals busybox /bin/ha. Inside the pod, we execute the command wget-qo-http my ClusterIP service. This command sends an HTTP request to the ClusterIP service. You should see the HTML message from nginx. Thank you for using nginx. This demonstrates that the service forwards traffic to the nginx pod. Finally, let's clean up the service and the deployment by using this command kubectl delete svc my ClusterIP service. kubectl delete pod my pod. This deletes the service and the pod when testing is done. In summary, in this hands-on session, we created a ClusterIP service for internal pod communication. We used both the declarative YAML method and the imperative command method. We also explored debugging and verifying service endpoints. ClusterIP services are essential for internal communication within a Kubernetes cluster. Thank you for practicing ClusterIP services in Kubernetes.